All right, everyone, welcome to today's Explainer. Go ahead and grab a seat, get your notebooks ready, because today we are fundamentally going to change the way you view the world around you. We're diving into atmospheric dynamics. Now, too often we look up at the sky and we just see, well, a void, right? We see this transparent, self-cleansing vacuum that basically just exists to be filled. But as your science professor for today, I'm here to tell you that is a profound illusion. The atmosphere isn't nothing. It is a heavy, tangible, highly complex infrastructure. Think of it as this invisible ocean that literally governs every single biological and industrial process on Earth. So let me ask you guys a question to kick things off. Have you ever felt the weight of empty space? I mean, really think about it. When you walk outside your front door, do you feel like you're submerged at the bottom of an ocean? Well, you should, because you are navigating through a heavy physical medium every second of your life. Today, we are going to completely shatter that illusion of transparent nothingness and get into the very real physics and chemistry of the air we breathe. Okay, here's our syllabus for today. We'll start with the invisible ocean around us, then move to the delicate chemical balance, look at industrial emissions and atmospheric theft, and finally wrap up with community mitigation and restoration. Let's jump right into part 1, the invisible ocean around us. Before we can even start talking about the chemistry of life, we really have to understand the physical bones of our environment. Now, air absolutely occupies space and exerts pressure. It's a heavy physical substance. To put that into perspective, the air inside your average living room weighs about as much as a large golden retriever. Crazy, right? When you blow up a balloon, it expands because air is actively filling that space, pushing out. And actually, a balloon filled with air weighs more than a completely empty one. It has mass. And because it has mass, it is entirely subject to gravity. Let's walk through the mechanics of the invisible here. Because air has measurable weight and density, it actually provides the lift required for global aviation. I mean, airplanes don't just fly on nothing. They're riding on a dense fluid. Air is also exerting constant atmospheric pressure in all directions. And without this pressure acting as a fluid medium for mechanical vibrations, sound waves literally couldn't travel. My verbal instruction to you right now would be physically impossible. You wouldn't hear a thing. Finally, air is highly compressible. We can squeeze it down into smaller volumes where it acts just like a mechanical spring. That's the entire foundation for pneumatic systems, bicycle pumps, industrial gas cylinders, you name it. Without these physical mechanics, modern civilization basically ceases to exist. Which brings us nicely to section 2, the delicate chemical balance. We've got the physical bones down, so let's examine the chemical blood that makes this whole system pulsate with life. Now, this breakdown here illustrates what I like to call the silent majority of our atmosphere. Just look at that massive chunk. Nitrogen makes up a staggering 78% of the air we're breathing right now. Oxygen, the fuel for our internal combustion, that's only about 21%. But here's the really wild paradox about nitrogen. Even though it absolutely dominates our atmosphere, in its gaseous form, it is relatively inert. It's inactive. You and I can't just breathe it in and use it. It requires incredibly complex natural cycles to actually become biologically useful for things like protein synthesis and plant growth. But I want you to focus on this number right here, 0.04%. That tiny sliver represents the concentration of carbon dioxide in our atmosphere. And let me tell you, in atmospheric science, significance is never dictated by volume alone. We call this the 0.04% paradox. See, on one hand, carbon dioxide has incredible industrial utility. Because it's heavy and it doesn't burn, we use it for fire suppression. We use it to carbonate our sodas. It is the primary reactant for plant photosynthesis. But on the flip side, the ecological risks of this tiny, tiny fraction are monumental. Because CO2 is such a potent greenhouse gas, even a statistically minute increase in that 0.04% drastically alters planetary temperature. We're talking global warming and ocean acidification. Plus, higher concentrations of CO2 literally reduce the oxygen-carrying capacity of our environments. That leads directly to diminished cognitive performance and respiratory discomfort in us humans. Honestly, it might explain why stuffy conference rooms make us all so sleepy. It is a razor-thin margin of safety.
Now, this natural equilibrium is driven by things like the nitrogen cycle. Remember how I said 78% of our air is inert nitrogen? Well, through this brilliant 6-stage process, which involves fixation by lightning strikes or specialized bacteria, this totally inert gas is naturally pulled right from the heavens, transformed into ammonia and nitrates in the soil, and becomes the biological backbone of our entire global food supply. It's just an elegant, perfectly balanced, natural symphony.
But what happens when human beings decide they want to rewrite that symphony? That brings us to Section 3, the core conflict of our explainer today: industrial emissions and atmospheric theft. I want you all to write this definition down: atmospheric hijacking. In this class, we don't look at air pollution as just an aesthetic nuisance or, smoggy air. It is a direct biological interference. When we pump synthetic pollutants into the air, they're acting as biological thieves. They're systematically sabotaging the chemical pathways of life, basically stealing our health and the structural integrity of our world.
Let's walk through this lineup, a rogues gallery of biological thieves. First up, carbon monoxide. This is the blood thief. Emitted straight from vehicle exhaust, it binds to your hemoglobin better than oxygen does, literally starving your vital tissues. Then we have sulfur dioxide, the infrastructure thief, which creates acid rain that corrodes metal bridges and eats away at historical stone monuments. Nitrogen oxides, often pushed out by industrial fertilizer processes and burning fossil fuels, act as the breath thief, causing chronic respiratory inflammation. CFCs, those are the ozone thief. And smoke particles are the lung thief. Guys, these aren't just accidental byproducts. They are active saboteurs of our human capital.
And these thieves certainly don't just appear out of nowhere. Factory emissions, vehicle exhaust, the open burning of fossil fuels and garbage, these are all anthropogenic, meaning human-caused disturbances. They're forcing a massive synthetic surplus into our perfectly balanced atmospheric system. And the effects cascade everywhere. We're not just looking at a spike in asthma rates, we're seeing degraded crop yields, permanent soil contamination, and a massive drop in workforce productivity because people are just sick and dealing with cognitive decline. So the science is incredibly clear, and the stakes are quite literally existential. Which brings us to our final section: community mitigation and restoration. How on earth do we bring this macro science down to local, actionable solutions? To restore that equilibrium and lock out those biological thieves, we have to implement what's known as the triple pillar strategy. First up, ecological sequestration. We have to address the sinks that absorb pollutants through aggressive reforestation. Trees naturally pull that excess CO2 right out of the air. Second, infrastructure transition. We have to address the sources by making a hard shift away from fossil fuels and towards solar, wind, and hydro energy. And third, industrial governance. We need strict, legally enforced regulations for factories to install advanced filtration systems. Honestly, voluntary compliance just isn't cutting it anymore.
But here's the thing. A macro-industrial shift has to be supported by local action. We have to bring all this high-level atmospheric physics directly into our own neighborhoods. And this is where your practical assignment for today's masterclass begins.
So, here is your homework class. These are the domestic prevention measures that support that massive global strategy. Stop the open-air burning of refuse and transition to clean cooking fuels. You absolutely must properly maintain your personal vehicles and household generators to ensure clean combustion. A poorly tuned engine is a massive source of nitrogen oxides. Reduce your use of harmful synthetic aerosols. And finally, get into localized landscaping. Go plant some trees and flowers in your community to immediately improve the air quality and the physical well-being of your neighbors.
Well, we've covered a ton of ground today. We've seen that the sky above us is absolutely not an empty void, but a heavy, physical, incredibly complex infrastructure. We live under the physical weight of billions of tons of air every single day. The invisible mechanics of this ocean sustain our voices, our industries, and the very breath in our lungs. So I'm going to leave you with this final provocative thought. We live under the weight of the air, but are we ready to live under the weight of our responsibility to protect it? Because if we really want to secure the visible future of our planet, we have to first learn to protect the invisible balance of our atmosphere. Class dismissed.